Today's lesson, we'll be talking about verifying trigonometric identities. Okay, now I've written out kind of the basic outline process that I kind of want you to follow when you're going through trying to figure out how to prove these identities. Okay, so my process is, if you're given an identity, so let's say I look over here, sine squared theta plus cosine squared theta equals 1. What you need to be able to do is to manipulate the left side. So if we were looking at our equation, this would be the left side, that would be the right side. Okay, and what I want to do is manipulate the left side so that it's exactly the same as the right side. Okay, so after I do a bunch of math, and I should have an equation that looks something like that, where it says 1 equals 1, and then I get to make a check mark to show that I correctly showed these. Now, the thing or the key to remember through all this is that they are equal to one another. Okay, you are verifying that these are indeed trigonometric identities. Okay, so if you're not getting it, you just need to try a different path, because they are equal to one another. They are the same. You just have to take different routes to get there. Okay, so that's the hard thing, is that it's hard to see what route you should be taking, but just know that there are multiple ways of doing the same problem. Now, when I go through this, I'm just going to go through the way I see it and explain that to you. But when we get to class and we actually do some of these, you may see it differently than me, and you might solve these differently. So that's okay. Now here, I just thought these were helpful trigonometric identities that we need to refresh on. So remember, tangent, same thing as 1 over cotangent, which is the same thing as sine over cosine. Cotangent is 1 over tangent, and which is the same thing as cosine over sine. Secant, same thing as 1 over cosine. Cosecant is the same thing as 1 over sine. And then your Pythagorean identities, so sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and a 1 plus cotangent squared equals cosecant squared. Okay, so these are things to keep in mind that we'll probably use throughout showing these. Okay. Now, there are also some different techniques. One thing that I like to do, usually, if there's not something super apparent right from the get-go, I always try to put things back into terms of sine and cosine whenever possible, and then manipulate it from there, because everything breaks down into sine and cosine, which is nice. And then once you do that, then something might show up, and then you can make it whatever you want. So, like, example 1, I have cosecant theta, tangent theta, multiplied to each other equals secant theta. Okay, so here, multiplying those two, there's nothing really super apparent, but let's change these into terms of sine and cosine. So for cosecant, it's the same thing as 1 over sine, and then tangent is the same thing as sine over cosine. Okay. Now, looking at this, notice how sine is you cross-canceling there, because you're multiplying two fractions. So I can cross-cancel these signs, and then once I multiply these together to simplify, notice what happened. So something just showed up out of just doing that kind of thought process that makes it so that you can simplify it. And we know that 1 over cosine is the same thing as secant. So like I said, I manipulated the left side to show the right, and notice how I get secant equals secant, and I get to make my check mark. Okay? Example 2. Now I have secant beta minus cosine beta equals sine beta tangent beta. Now here somehow I'm supposed to be able to get two things that are subtracting to one another to make them into multiplication. Okay? So same technique. Try to make them into terms of sine and cosine. First, so like here, secant, we can change to cosine of beta. Now cosine's already in terms of cosine, so I don't really have to do anything to it. Now, another technique that you want to be aware of is that when you make fractions and they're subtracting or adding to one another, it's usually a good idea to put those two fractions together. Okay? That's kind of why I gave you the algebra review worksheet, so that you could review working on putting or making common denominators and then putting the fractions together, because that usually is a good idea or a good thing to help you put things together and verify these identities. So here I need a common denominator between cosine and 1. That's cosine, so I'm going to multiply top and bottom by cosine of beta. Okay, so then here in the numerator I have 1 minus cosine squared beta over cosine of beta Okay, now looking at this, maybe it's not super apparent what we need, but let's go back to our trig identities. If you notice, sine squared plus cosine squared equals 1. That's usually a key for me, is if I see something squared, it must lead me back to a Pythagorean identity. Okay, so I can manipulate these however I want. So let me show you. If, let's say, I subtracted cosine squared to both sides, you would get the identity of sine squared theta equals 1 minus cosine squared theta, which is what we have in that last picture. So let's go back and let's insert sine squared beta in for 1 minus cosine beta, or cosine squared beta. Okay, and then from there, now I need two things. So I need a sine and a tangent. But like here, I have two sines at the top. Now let's say if we can, one thought is, because I need two things, let's separate the numerator into two things that are multiplied to one another, because I need two things multiplied to each other if I look to the right. So that would tell me that maybe I should separate it somehow by multiplication. So let's say I say sine beta over 1 and sine a beta over cosine of beta. Well, now that kind of looks like what I have on the right, where sine of beta over 1 is sine of beta, and then sine over cosine is tangent. So there you go. I got both sides to equal one another. So that's a check mark. Now, sometimes maybe I don't want to make everything a fraction and do that kind of stuff, because sometimes that would make it harder. Like here I have two binomials multiplied to each other with secant. So if I made it 1 over cosine and for both of them and then multiply, I'd have two fractions and it might take a little different. So maybe combining them by multiplying would be a better route for this one. So make less terms, and then maybe we can see if that's something I want to do. So let's multiply these two binomials. So secant times secant gives me secant squared alpha. Secant times 1 is secant alpha. Negative 1 times secant alpha is negative secant alpha. And then negative 1 times 1 is negative 1. Okay. Now here, secant alpha minus secant alpha cancels each other out. So I get rid of that term that I don't want. Okay, so now I'm left with secant squared alpha minus 1 equals tangent squared alpha. So then now, secant squared. Okay, so if I look back at my Pythagorean identities, okay, there's a secant squared, there's a tangent squared. Okay, now let's say I subtracted that 1 over, did a little manipulation, wrong variable. So then subtracting 1 gives me secant squared alpha, or theta, minus 1. So here in our problem, we have secant squared alpha minus 1, which is very similar. Doesn't have to be the same variable. So now, that's the same thing as tangent squared. Okay, there's a check mark. Now make sure when you're doing anything squared, or when you're thinking it's a Pythagorean identity, don't just assume it's something, because sometimes, like if that was a plus 1, we wouldn't be able to do it, or if it was 1 minus secant squared alpha, then we wouldn't be able to do it, like the order is different. So make sure you check to make sure with your Pythagorean identities that they are correct, and that you're using the right one, because sometimes it gets kind of tricky that sometimes it won't work, like it's not the right one. Okay, last one. Here, now you start with a fraction. Now you want to be able to have two things. So like right now, how about we separate these two things so that I have something plus something and not have this weird fraction going on. So tangent of x over sine of x and cosine of x over sine of x. Now when looking at it right now, and looking to my right, what I need to get, because I need to get a secant and I need to get cotangent. Now looking at the right side of my plus sign, that's cotangent. So I've already got part of my thing. Okay? Now, the secant part, it's a little harder to see since you have tangent over sine. But, like I said, sometimes maybe putting everything in terms of sine and cosine might make it easier to determine what's going on or what to do next. So here, tangent, let's change that to sine over cosine. Now here, that looks like a complex fraction. So let's put the bottom sine of x over 1, and let's multiply it by the reciprocal. Now looking at that, it looks like my sines actually cancel out, which leaves me with 1 over cosine which is the same thing as secant. Okay, and there's my answer. Check mark. So here, those are some of the techniques I like to think about. Think about putting your everything in terms of sine and cosine to see if that gives you something. Look out for your squares, because they might be a Pythagorean identity that you can use to help you out. Anytime you have fractions, sometimes putting them together makes sense. But also look at what you have to the right and what you want to get, and try to match up or make your left side start to look like that, and then something might evolve from there. Okay? So some ideas. Have fun.